everyone. Before all, I would like to pass the warm regards of our Managing Director, Mr. Stavros, who was initially registered to be present today, but unfortunately he is out overseas on business purposes, and I will try to replace him, although it's difficult to replace Konstantinos. Right, so I think we have heard very interesting opinions and statements around the overall scheme. Today, we are planning to touch in this section of the presentation the innovative technologies around decarbonization. And before, I would like to introduce ourselves. So we are ERMA FIRST, we are a Greek equipment manufacturer and solution provider. Together with our affiliated companies, we are serving the market for more than 45 years. And now the next day in ERMA FIRST, the evolution internally is that we are trying to address the decarbonization challenges with specific technologies. Those technologies include the alternative maritime power systems, energy saving devices, actually machinery related, and also carbon capture systems. And allow me to start with the alternative maritime power, which is actually the technology that explicitly is stated on the FuelEU maritime regulation, and specific ships must follow after 2030 when they are berthing on European ports, but not only. The technology is not actually new. Probably the oldest one may remember it calling cold ironing. This is coming from the US Navy times. Shoreside electricity is another name, high voltage shore connection, OPS as Europe wants to say, and alternative maritime power. Actually, we are talking about shoreside and vessel-side infrastructure. I'm not going to dive deep in the elements. However, it needs close collaboration and cooperation between those two systems, and I think here is the main challenge. Speaking about regulatory compliance, as of today, US is leading the regulation, specifically California, with container, reefer and passenger ships being already in regulation since 2022. Tankers will be under regulation in 2025 for ports of Long Beach and Los Angeles, with the remaining ports to be under regulation for tankers in 2027 in California. In Europe, as we said before from Mr. Kokarakis as well, in 2030 container ships and passenger ships shall be under regulation according to FuelEU maritime, and at the same moment China is also developing significantly, placing specific rules currently for the Chinese flag vessels, but there are rumors that those will be extended to, probably with incentives, to other flagships as well. And whatever is, let's say, applied as a regulation, there are some standards behind it, especially for cold ironing, where, as we said before, it needs this close cooperation between port and ship. Three big organizations, ISO, IEEE and IEE, collaborated together and have issued the gold standard, or the Bible as we say in our language, 8005 standard. It's comprising of three parts. Part one are the high voltage systems, part two are the communication protocols, and part three are the low voltage systems, actually vessels where the power demand is less than 1 MVA. This standard is, I said, is the gold Bible because here it stipulates the voltage and frequencies per ship type, also the shore connection interface, where, for example, the cable management system, this cable reel probably you have seen, shall be on board only for container ships. All the other vessels will be equipped with plugs, and actually specific plugs. Not all plugs are the same. So there are many technical challenges around the configuration of such systems. What I want to highlight from this map is that currently There are normative standards for container ships, passengers, vehicle carriers, cruise ships, but informative for tankers and LNGs. And here I think there will be some more discussion between the regulators about placing some more specific standards in order to avoid difficult situations. We in ERMA FIRST, we have translated, I would say, this standard, and utilizing the know-how and the experience, we have developed systems. Those systems can be fixed, containerized, or portable systems. These are configured based on the power supply capacity, but also from the way that those are plugged on board, meaning on port or starboard. At last, I would highlight again that this is not new technology, but this is the first time that this technology is applied on board commercial industry, and actually high voltage is probably the first time that is applied to commercial industry. And I will come to Mr. Kakalis, as he said before, the human factor is very important. So safety must be maintained. And in this respect, I want to highlight the importance of IoT and control systems that shall be developed not only to be reliable and let's say robust, but must provide safety for the first for the seafarers and then for the equipment. Moving forward to the energy saving devices that we have developed in ERMA FIRST, there are many energy saving devices, as we said before, and have been presented. We have focused now on the machinery part. So we have developed a product called Flex Cap. Actually is a propeller cap, and it is addressing the hub vortex that is mainly we can see on the standard propellers. This results to optimization of the fuel consumptions at the levels of 3 to 8%, and at the end of the day it improves in a certain range the CII of the vessel. However, I can tell you that not all devices or propeller hubs are equal and are offering the same performance. Here you can see from CFD that we are doing in-house that difference between 5 degrees on the fin angle and size provides more than 1% difference in performance. In ERMA FIRST we have developed this device with modular fins, and so after a CFD that we are doing in-house, we are working to optimize the performance of the ship according to the specific ship design. And moving forward to the, let's say, last part of the innovative technologies, we're talking about carbon capture and storage systems. Obviously, these systems have an imminent effect on the optimization of the performance of the CII. The systems are rated according to the capacity, meaning kilograms per hour, and obviously the higher is the system on the absorption capacity, the higher is the performance. This has imminent also effect on monetary gains, further to environmental gains. It has imminent effect to monetary gains, and if we follow the trend that probably the CO2 trade in future will be at a ballpark of 200 euro per ton, for a 25 ton, let's say, per day CO2 system, the gains for the ship can be at the ballpark of around 300,000 euros per year. However, things are not as rosy as it looks, because we are talking about chemical plants to be installed on board. And I don't want to scare you, but this is the truth. In ERMA FIRST, we have worked on that, and we have developed or we have utilized two technologies. First technology is the CO2 capture with calcium hydroxide. So here we are using this strong inorganic alkali agent to absorb CO2. Then the flue gas in contact with the calcium hydroxide is driven in a reactor where the treatment takes place, and the resulted calcium carbonate slurry is then dehydrated and stored on board. The problem with this technology is that we have big volumes of chemical to be received and also stored, and thus this makes the technology only applicable for short sea voyages. To address the deep sea going vessel technology, we have, or let's say requirements, we have utilized a technology that is coming from land-based plants. This solution utilizes an amine absorption technology, and this amine is actually absorbs CO2 from the flue gas in a dedicated absorber. The beauty with that is that this absorber and stripper following is 10 times smaller than in footprint than a land-based equipment. The CO2 then rich solvent is directed to a stripper, as we said, where heat regenerates the amine, and this is a continued process, and then releases CO2. The CO2 later on is liquefied and stored under cryogenic conditions on board the ship. So you understand that there are a lot of equipment and a lot of process and control that shall take place on board. The final product of CO2 is food grade, is more than 99.9% on CO2. However, this technology needs high power and steam requirements. At the end of the day, what I want to highlight, and as also this previous speaker noted, that it's not an easy task, the selection of proper technology on CO2 system. That's why a feasibility study is very important. We need to evaluate the age of vessel, the technical specs of main engine, the operation profile. We need to work close with operator and with the manager of the vessel. And finally, we need to evaluate if there is a vessel pool included in the fleet in order to allow for EU allowance trading schemes. And with that, I would like to finalize stating that we are working close with all the authorities, with the regulators, with classes. The systems that we have currently designed, they have received approval in principle, both the carbon capture systems, but also the AMP1 from Bureau Veritas, and furthermore, the AMP system has been audited by DNV, and we have received a letter of professional experience stating that our AMP solution is considered an ESD device that optimizes the CII index of the vessel. And thank you very much for your attention, and I'm happy to address any further questions.